Welcome back to the session on numerical differentiation. In the previous session, we discussed the numerical differentiation using the Newton's forward interpolation formula. Here, we shall discuss the numerical differentiation with Newton's backward interpolation formula. When n plus 1 pairs of values x naught, y naught, x1, y1, etc. xn, yn are given, the Newton's backward interpolation formula is given by y is equal to y naught plus u by 1 factorial into not y naught, yn plus u by 1 factorial into del yn plus u into u plus 1 divided by 2 factorial into del square yn plus u into u plus 1 into u plus 2 divided by 3 factorial into del cube yn plus etc., where u is equal to x minus xn divided by h. We differentiate this expression with respect to x. On both sides, we get dy by dx is equal to, here dy by dx means d by dx of dy by dx into dx by du, because the right hand side is a function of u, where u is a function of x. Therefore, we use the chain rule, function of function rule, which is equal to, here u equal to x minus xn by h. Therefore, du by dx is equal to 1 by h. Therefore, this is equal to 1 by h into yn is a constant, therefore, derivative is 0. Derivative of u is 1, 1 by 1 factorial is 1. Therefore, del yn is a constant, plus here u square plus u, the derivative is 1 by 2 factorial into derivative of u square is 2u plus derivative of u is 1 into del square yn plus next is 1 by 3 factorial into, here we use the product rule of differentiation. We get 3u square plus 6u plus 2 into del raised to 3 yn. Plus etc. The next term is plus 1 by 4 factorial into 3u square, 4u cube plus 18u square plus 22u plus 6 into del raised to 4 yn plus etc. Now, we differentiate once again, we get d square y by dx square, which is equal to 1 by h. Here 1 by h is also there. In the next differentiation, there is one more 1 by h. Therefore, 1 by h into 1 by h is 1 by h square into delta yn is a constant, therefore, derivative is 0. Here the derivative is 2 by 2 factorial is 1. Therefore, this term will become del square yn plus derivative of this is u plus 1 del cube yn. plus this is 1 by 12 into 6u square plus 18u plus 11 into del raised to 4 yn plus etc. This is the second derivative. We differentiate once again, we will get d cube y by dx cube as 1 by h cube into del cube yn plus 1 by 2 into 2u plus 3 del raised to 4 yn plus etc. These three formulae for derivatives may be used to find the first three derivatives of y at any point x equal to x k, where x k lying between x naught and x n, or x k is very close to x n, or x k is very close to x naught, if it is x k is out of the interval x naught x k. Here, if x equal to x n, these three formulae will become x equal to x n means u equal to x minus x n by h will become 0. Therefore, the first derivative will become dy by dx at x equal to x n will become dy n. We have to use this notation, capital D. D means the differential operator. Dy n is equal to 1 by h into del y n plus 1 by 2 factorial into del square y n. U is 0, therefore, this is del square y n plus 1 by 3 into del cube y n. The next term is 1 by 3 into del cube y n. The next term is 1 by 4 into del raised to 4 y n plus etc. The second derivative will become d square y by dx square at x equal to x n. That means capital D square y n, which is equal to 1 by h square into here del square y n plus u is 0, therefore, this is del cube y n plus the next term is 11 by 12. This 2 will become 0, therefore, this is 11 by 12 del raised to 4 y n plus etc. And the third derivative is d cube y n, which is equal to 1 by h cube into del cube y n plus 3 by 2 del raised to 4 y n. The next term is 7 by 4 del raised to 5 y n plus etc. We can use the differential operator notation capital D and the forward difference operator capital delta, and we can write these expressions as capital D is identically equal to 1 by h into del plus 1 by 2 factorial into del square plus 1 by, sorry, here 1 by 2, 1 by 3 del cube plus 1 by 4 del raised to 4 plus etc. And this is 1 by h square, that is d square equal to 1 by h square into del square plus del cube plus 11 by 12 del raised to 4 plus etc. And this is d cube equal to 1 by h cube into del raised to 3 plus 3 by 2 del raised to 4 plus 7 by 4 del raised to 5. These are relations connecting capital D and del we just proved in the beginning of finite differences. Now we have an example, that is from a given data we can find the derivative. The given data is the values of x are 1.5, 2, 2.5, 3, 3.5 and 4. The values of y are 3.375, 7, 13.625, 24, 38.875 and 59. These are the given data. Now, first of all, we have to evaluate f dash at x equal to 3.5. We have to find f dash at 3.5. That is the first derivative of f at 3.5. We construct the difference table. The first differences are 7 minus 3.75 is 3.625, 13 minus 13.625 minus 7 is 6.625, 24 minus 13.625 is 10.375, 38.875 minus 24 is 14.875, and 59 minus 38.875 is 20.125. The second order differences are del square y, that is 6.625 minus 3.625 is 3. This is 10.375 minus 6.625 is 3.75. 14.875 minus 10.375 is 4.5, and this is 20.125 minus 14.875 is 5.25. The third order differences are 3.75 minus 3 is 0.75, 4.5 minus 3.75 is again 0.75, 5.25 minus 4.5 is again 0.75, and the fourth order difference are 0, and the fifth order difference also is 0. The formula for derivatives is dy by dx is equal to dy by dx at any point x equal to some xk is given by 1 by h into the first derivative is given by 1 by h into del yn plus 1 by 2 factorial into 2u plus 1 del square yn plus 1 by 3 factorial into 3u square plus 6u plus 2 into del cube yn plus 1 by 4 factorial into 4u cube plus 18u square plus 22u plus 6 into del raised to 4 yn plus etc. This is the formula for first derivatives. Here u is equal to x minus xn by h, that is x is 3.5 minus xn is 4 divided by h is 0.5. Interval of difference is 0.5. This is equal to minus 0.5 divided by 0.5, that is minus 1. Here u equal to minus 1. This is equal to 1 by 0.5 into delta yn is this is yn is 59, this is del yn, this is del square yn, this is del cube yn, and this is del raised to 4 yn, and this is del raised to 5 yn. Therefore, the first derivative at x equal to, here xk means 3.5, which is equal to 1 by 0.5 into del yn is 20.125 plus 1 by 2 factorial is 2 into 2u plus 1, u is minus 1, therefore, this is 2 into minus 1 plus 1, del square yn is 5.25 plus 1 by 3 factorial, 3 factorial means 6 into 3 into u square is u is minus 1, therefore, minus 1 square plus 6 into minus 1 plus 2 into del cube yn is 0.75, and the fourth difference, fifth differences are all are 0, therefore, both are 0, therefore, one simplification, this is equal to 1 by 0.5 is common. On simplification, we will get this as 34.75. That is the first derivative at x equal to 3.5, that is f dash of 3.5 is equal to 34.75. The next example is we have to find the value of f double dash at 5 from the given data. The given data is the values of x are 0, 1, 2, 3, 4, 5. And the corresponding y values are 4,930, 5,026, 5,122, 5,217, 5,312 and 5,407. First of all, we have to construct the difference table. The first differences are 5,026 minus 4,930 is 96. The second difference is also 96. This is 95, 95, and the last one is again 95. The second differences are 0, here -1, this is 0 and 0. The third differences are -1, 1, 0, and the fourth differences are 2, -1, and the fifth differences are -3. This is the corresponding difference table. Based on Newton's backward interpolation formula, the second order derivative d square y by dx square at x equal to xn, here xn is 5, is equal to 1 by h square into del square yn plus del cube yn plus 11 by 12 del raised to 4 yn plus 5 by 6 del raised to 5 yn, which is equal to, here h is the interval of differencing is 2 minus 1 is 1, that is 1 by 1 into del square yn is this is del square yn, this is del cube yn, del raised to 4 yn, this is del raised to 5 yn. Therefore, this is equal to del square yn is 0 plus del cube yn is 0 plus 11 by 12 into del raised to 4 yn is -1 plus 5 by 6 into del raised to 5 yn is -3. On simplification, we will get this is equal to -3.4167. Here we used this expression because we want to evaluate the second derivative at xn. Xn means the last value, end value of the given data. Therefore, on substitution we will get the second derivative as negative 3.4167. Now, let me conclude this session. In this session, we discussed the differentiation formula based on Newton's backward interpolation formula. Thank you for watching this session. Have a nice day.